Hello, good morning, class. Today we are going to discuss something about numerical solutions of ordinary differential equation. Now, when we talk about numerical solutions, they are the methods that are used to approximate mathematical problems, and precisely those that we cannot solve it analytically. So let's say we are having s power 4 plus s power 3 plus s squared plus s equals 7. For this question, we know that it's quite difficult for us to get our roots, and we are expected to find x4 or x1, x2, x3, and x4. These are roots that we are going to find, and it's quite different from finding quadratic equation. So at this instance, numerical solution will help us to find our way out. And some of the method we can use to solve these questions is that approximation method, using the approximation method, or interpolation method, or iteration method of iteration, the iteration method. It will help us to find our roots. So that is numerical solution. When you're having a tedious question and you want to solve it, you must go with the numerical solution method. Very good. So that is numerical solution. And talk about ordinary differential equation. Let's say differential equation. When you talk about differential equation, they are equations that has at least one independent variable in an equation that is having at least one independent variable. And we're having two types of differential equation. We're having the ODE and PDE. So types of differential equation is we're having ODE and PDE. We talk about ODE, it's the same as ordinary differential equation. This is an equation that is having one independent variable. So every ODE is having one independent variable. But for PDE, they have at least one independent variable. So they are more than one. That is 1, 2, 3. That is for PDE. Very good. So for ODE, it can be written as y prime or y prime prime or dy ds or the square y on ds square. So this is how we represent ODE. But for PDE, we represent it as u of x, u of xx, u of xyx. So this is how we also represent PDE. I said that they are having one or more independent variable. When you talk about the independent variable, let's say Mr. Savage is having a maize farm. My maize farm depends on some factors. It depends on time, it depends on the fertilizer that we use, it depends on the soil fertility. And the harvest depends on the time. So the time is an independent variable, but the harvest is a dependent variable. So to harvest a larger quantity is depending on the time, my soil fertility, and also the fertilizer that I applied in my maize farm. But the harvest is the dependent variable. Same thing applies here. We are having the y as the dependent variable. The y is the dependent variable and the x is the independent variable. So it means that we can't dealt away with this one. Very good. So that is the dependent variable and the independent variable. And I said that for ODE, it's being represented as y prime or y prime prime dy ds or the square y over ds square. So this is how we represent ODE. Now today we are learning about numerical solution of ordinary differential equations. It means that we'll be coming across these signs with these symbols that we see on the board. So example of ODE, we are having y prime of. This is an example of ODE. This too is an example of ODE. So this can also be written as very good. So all these things are example of ODE. So we'll be using this form of questions in our solution. So we are having several methods that we use to solve ordinary differential equation. Now we are going to start with the Taylor's method. After that, we move on to the Picard method. So for today, we'll be discussing about the Taylor's method.